Welcome to this video, which is going to go over differentiation using the chain rule. We're going to look at when we can use this method, go over some examples, and hopefully clarify just the basics of what to do with this method. Okay, let's start. So the chain rule is applied when we have a function of a function. More formally, it's called a composite function. Let me give you some examples. So y equals sine of 2x, that is a composite function, okay? Because we are going to take x, multiply it by 2 first, that's one function. And then I'm going to take the sine of it, okay? So it's a composite function going on there. However, y equals 2 sine x, that is not a composite function. Okay? So y equals x plus 4 all squared, that is a composite function because I've got to do something in the brackets first, okay? Once I've done that, then I'm going to square it. Conversely, if I were to actually just multiply the brackets out, I could do that, x plus 4, x plus 4, like that. If I was to multiply it out, I'd end up with that. Now, the expanded form is not a composite function, okay? There's no need to apply the chain rule for that. This is what you might have been used to in schools. If you have a function y, which is f of u, another function u, which is g of x, then the composite function will be y equals f of g of x. Okay, so that's all very good, but let's have a look at an example of what that actually means. So suppose y is u cubed, but u is actually x plus 5. So the composite function would then become, going to take x plus 5 and substitute that in for u, and we get y equals x plus 5 all cubed. If that is the case, then what we can basically do is differentiate things individually and use that to help us find dy by dx, because that's what I'm looking for, okay? So let's apply this. I've got y equals u cubed, so dy by du would be 3u squared. If u equals x plus 5, then du by dx would be 1. If I wanted to put it all together, I'm going to get dy by dx equals dy by du, which was this here. That's 3u squared multiplied by du by dx, which was 1. But we don't want to leave it all in terms of u's. I want to put it back in terms of x's. So we know u was actually x plus 5. So I've got 3 lots of x plus 5 all squared times 1, but I don't need to write that down. Now that's quite cumbersome, having to write it all like that formally. So let's go over a quick method to help us do this. Okay, so this quick method, what we do is we differentiate it as a whole, and then we multiply by the inside differentiated. Now, this is my inside, okay, the yellow bit highlighted. This is my inside. That is my inside bit. So I've highlighted all of that. Okay, so I'm going to differentiate it as a whole. Basically, I'm going to ignore the yellow bit initially, and then I'm going to multiply by the yellow bit differentiated. Okay, so the inside differentiated. Okay, let's see what that looks like. So I've got dy by dx equals, right, that's a power 7 there. Let's bring that down. So 7, ignore the bracket for now. So I've got 4x to the power 5 plus 2x. 7 becomes 6 because I've differentiated it. Okay, so I've differentiated it as a whole. Now I need to multiply by the inside differentiated. So what's the inside differentiated? 4x to the power 5 becomes 20x to the power 4 plus 2. So let's tidy that up. What do we get? 7, 20x to the power 4 plus 2, 4x to the power 5 plus 2x all to the power 6. Okay, so this was that yellow bit there was my inside differentiated. Okay, let's have a look at the middle example. Okay, so I've got y. Again, I'm going to differentiate it. So dy by dx, I'm going to bring that 4 down, so that becomes to the front, 4 lots of 4x cubed plus 7. That 4 becomes 3, multiplied by the inside differentiator, so 12x squared, and that's it. This can be tidied up nicely because 4 times the 12 gives us 48, x squared, 4x cubed plus 7 cubed. Okay, last one. Now this one isn't easy to differentiate it in its current form, so I'm going to write it using indices. So y equals 2x to the power of 4 minus 1 to the power of a half. Okay, so now I'm going to differentiate it. dy by dx, same rule. So bring the power down. I've got a half. Ignore the inside for now. 2x to the power of 4 minus 1. Take 1 away from the power. Multiplied by the differentiation of the inside. So that's me 8x. Okay, let's tidy that up a little bit. A half times 8x is just 4x. And then that becomes 2x 4 to the power of 4 minus 1 to the power minus a half. Now this, we can rewrite it as 4x over the square root of 2x to the power of 4 minus 1. That's it. I don't want to do anything more to it. Okay, so that's your quick trick. Let's do some examples using the formal method. So here we're going to use a bit of substitution. I'm going to look at what's easy to differentiate. That's this bit here. So let's call that u equals 6x to the power of 5 plus 4x. Okay, and then therefore y equals u cubed. So y is now really easy, straightforward to differentiate. I'd get dy by du equals 3u squared. Du by dx equals 30x to the power of 4 plus 4. Right, now we're going to do some substitutions. We've got a du by dx, so that's my du by dx. Need a dy by du. Here's my dy by du. So putting it all together, dy by dx equals 3 lots of u squared times by du by dx, which is 30x to the power of 4 plus 4. But I don't want to leave the u's in there. So let's put our substitution back in. What was u actually? 3 lots of 6x to the power of 5 plus 4x, 30x to the power of 4 plus 4. And check, can we use a quick method to get the solution directly? Ideally, that's what we want to be doing. Okay, so ideally you want to go straight from there to there. You don't really have time to do all of this. So check if you can do that. Right, here's a little bit of a you try. I want you to pause the video and have a go at doing this yourself. Try using the quick method if you can. And when you press play, you'll see the answer. Here is your solution. Let's do the quick method here. This is what we're dealing with. So we've got dy by dx equals, there's my 3. Bring that down. So I've got 3, 6x to the power of 5 plus 4x. I want to take 1 away from the power because that's what I would do normally. Finally, we have to multiply this by the differential of the brackets. So what does that get me? 6x to the power of 5 is 30x to the power of 4 plus 4. And that's it. I could leave it like that, or we could rearrange it as 3, 30x to the power of 4 plus 4, 6x to the power of 5 plus 4x all squared. Here's another example. I'm going to do the formal method with you again, just so that you can see how it works, and hopefully you can check with your quick method in there. Firstly, we want to rewrite that because this is not written in a nice way to help us to be able to differentiate. That is 1 plus x squared to the power of half. Okay, so let's do some substitutions now. Let's let y equal u to the power of half, because that is easy to differentiate. If I let u equal to the power of half, that must mean u equals 1 plus x all squared. Okay, let's do the individual differentiation. So dy by du is a half u to the minus a half. Du by dx ends up being 2x. Okay, du by dx, we've got that over here. And we need dy by du, and I've got that over here. Okay, let's put everything together. So I've got dy by dx equals a half u to the minus a half multiplied by 2x. Let's tidy that up because I don't want to leave a u there. So that u is actually equal to 1 plus x squared. So, and then that 2, this a half will cancel with that 2 over there. So that'll get me x lots of u to the power minus a half, use 1 plus x squared minus a half, which is actually x over square root of 1 plus x squared. Okay, either way you can do it. Right, you have a go at this. Pause the video, see if you can do this. Again, ideally you want to use a quick method. Okay, here's your solution. So firstly, we want to rewrite that. Y equals 3 minus 4x to the power a third. Remember, we want it to be an index form to help us differentiate. So dy by dx. Again, I'm going to ignore the bracket for now, differentiate it like it was not anything in there. So a third comes down. 3 minus 4x, right, a third minus 1 gives me minus 2/3. Now I've got to multiply it by the differential of the bracket. So the differential of the yellow bit is minus 4. That's my differential. Putting it all together, I've got minus 4/3 of 3 minus 4x to the power minus 2/3. We could have written that as minus 4 over 3 lots of 3 minus 4x to the power of 2/3. And that's also fine as well. Thank you for watching. Hope you found it useful. If you did, please drop me a comment, like and subscribe. Your support is much appreciated. Bye.